All right, now let's look at another worked example. It's saying evaluate 5 cos squared 3 theta with respect to theta. So here, I see I have a cos squared again, and automatically in my gut, I know that I'm going to use the cos 2x, the double angle identity, and this says that cos 2x is equal to 2 cos squared x minus 1. Well, in our case, we have theta, so we can say cos 2 theta is equal to 2 cos squared theta minus 1. Remember, we're going to make cos squared theta the subject of the formula like we did, and it's going to be cos 2 theta plus 1, because this negative 1 comes there, becomes plus 1, is equal to 2 cos squared theta. We divide both sides by 2, and dividing by 2, we say it is like half. So it's going to be half cos 2 theta plus 1 equal to this 2, and this 2 cancel, equal to cos squared theta. Now, if we evaluate this, that's the same thing we do. So that means the integral of from 0 to pi over 2 of 5 cos squared 3 theta d theta. Now, if you see something here, is that instead of having a cos squared theta, we now have a cos squared 3 theta. So in other words, wherever there's theta, we have 3 theta, okay? So wherever there's theta, we now have 3 theta. So we could now say, well, this would be half goes outside, We say that this half, then we say the integral of cos 2 by, the theta is now 3 theta plus 1. And we are integrating with respect to theta. And that will be half multiplying the integral of cos 6 theta plus 1 all with respect to theta, right? If you want to split it still, you can still do that. It's now half, but now it's multiplying the integral of cos 6 theta d theta plus the integral of 1 d theta, or we can say the integral of d theta only, 1 with respect to theta, right? So this would be half multiplying the integral of, and don't forget the bounds, is 0 to pi over 2. It's 0 to pi over 2, and it's 0 to pi over 2, and that's the same thing here, 0 to pi over 2. Well, half the integral of cos 6 theta with respect to theta would be sine. So it would be sine 6 theta divided by 6. Okay, the derivative of that. And then you say plus the integral of 1 with respect to theta is theta. Okay? And the bounds are from 0 to pi over 2. So now we have half outside, still multiplying. Well, when we take the first case, that is when theta is pi over 2, then we subtract when theta is 0. So it would be 6 sine of 6 by pi over 2. And that's going to be 3 pi, right? Over 6 plus pi over 2. Okay? Then minus sine of 6 by 0, which is 0. Okay, over 6 plus 0. Okay, now this will be equal to half sine 3 theta divided by 6. You could say sine 3 pi. So here I would have my values for the angles, or I would have to use my calculation with my angle in radians. Okay, so I could say sine 6 pi, all right, so for say sine of 6 pi, I'm going to get 0. All right, sine 6 pi is 0. So divided by 6, that's 0. So it'll be half of 0 plus pi over 2, that's pi over 2. Okay, and this, I now say this minus sine of 6 by 0 is 0. Sine 0 is 0 again. Divided by 6, that's 0. Plus 0. This is 0, not theta anymore. And that doesn't add anything, so it's minus 0. So it's the final answer would therefore be pi over 4. This is how you evaluate the integral. Well, the main thing was to see that whenever I see a cos squared, then I'm going to introduce the identity of cos 2x that is related to cos squared x, and that is what I'll then use to find my final answer. Okay, that's it. Goodbye. See you in the next video.